Audio recording for this meeting has begun.
Okay, my name is Molly Marin. I am the webinar coordinator for the New York State RTI Technical Assistance Center. Just a few reminders before we get started today. A copy of today's PowerPoint is available on our webpage. If you have not gone out and grabbed that, you're welcome to do so. At the end of today's presentation, I will post a link to an evaluation. If you could please take a few minutes, it's very short, and we very much appreciate the feedback. Also, if you were on with us last week, we had a number of questions and we couldn't get through them all. Dr. Gersten has responded to those, and I'm going to work to try to provide those via our webpage for you. Just need a little clearance on that. So you can watch for that. Also, throughout today's webinar, feel free to use the chat box for any questions or comments you may have. Dr. Gersten will likely break at midpoint and answer some, and then we'll be answering, have some time at the end to answer them. Today is the third webinar in our Understanding RTI in Mathematics series. Our final webinar in this series will be next Tuesday. We also have our database decision making in an RTI process series going on right now. First one was yesterday. More information and registration information on all of our webinars is available on our webpage at nysrti.org. We are very pleased to have Dr. Russell Gersten back with us again today. Dr. Gersten is a professor with the College of Education at the University of Oregon and director of Instructional Research Group in Southern California. He served on the National Math Panel, co-chairing the Committee on Instructional Practice. He also chaired the panel that created a practice guide for RTI mathematics for the NYS Department of Education. In his 20s, he reviewed R&B for Rolling Stone and the Boston Phoenix and interviewed many of the stars of that era, such as Al Green and Gladys Knight. Welcome, Dr. Gersten.
Thanks, Molly, and good afternoon, everyone. This is the third webinar in the series, and the focus of the series is understanding RTI in math. And in some ways, what we're going to really try to emphasize is the evidence base and where the evidence base falls down or there just isn't much evidence, and some of the principles, because one of the key things that people are beginning to really understand, think about with RTI is going back at some point from
your microphone has been turned on.
What is the purpose? What is the focus? Why are we doing this thing? One thing that came up last week when we talked about screening was the fact that in some schools there are just all these different tests. There are district benchmark tests. There are some program for progress monitoring and screening like GamesWeb, Easy CBM, some DIBBLES program, whatever, in math. And the whole idea is how do all these pieces fit? And the focus today is on actually what we know about delivering effective interventions in Tier 2. We will start with a couple of polls, which just gives me and all of you a sense of who we are. So these are both quick questions, and it's poll 1 and 2. Shouldn't take long at all. I think we have a pretty good sense of the profile, and as has been typical in these webinars, folks come from all kinds of diverse positions related to RTI, and that most of you feel you have some knowledge of RTI in math. Some of you feel you have a lot of knowledge, which is great, because I hopefully present some sophisticated material here. This is basically what we're going to focus on, basically what to teach and how to teach, and I'll very briefly go through materials and resources and also share the citations, and then, of course, this is archived, so you can look at this at your leisure. The core source, again, is the practice guide, the RTI practice guide that came from the U.S. Department of Education, was out about 7 years ago. And this is a listing of the panelists who helped put this together. And I chaired the group, and it was based on research going up till about 2006 or 7. I'm going to update some of the research a little bit. I have a couple other poll items just to get you in the frame for looking at what we're teaching in RTI. So here they are. Okay, and I think we have a good sense, and Molly, you let me look at these for another second, that over half of you feel we have a long ways to go in RTI and math and doing it in a way that makes sense. And I think that probably is reflective of many in the country, and then some feeling that it's okay, that it's moving in a good direction. It has received far less attention and funding and support and regulatory support from states, and there also is a lot less research. One thing we can celebrate a bit is in the last decade, especially the last 5 years, there's a lot more research to guide us. And I'm glad that the two issues that come up that are probably the most frequent issues is what to teach, because I'm going to spend a lot of time on that, a lot more probably than others might do. And the other key issue is whether to use the assessments embedded in the curriculum. And that issue I think I'm going to address in a second. Grouping for Tier 2 intervention, since that was more a topic from last week, I'm just briefly going to address that before we get into what to teach. The grouping, I think as a rule of thumb, it'd be great to use formative assessments, good diagnostic tests. A lot of that technology is being developed. It's not developed yet. I think as a rule of thumb, as it's not bad to start off with scores on a screening battery, just to get a sense that of roughly, because what you don't want is a small group where of 5 where 2 are moving at so much of a different rate, and so it's fine to cut across groups, classrooms if need be, etc., even grade levels if need be. And we talked a little about, and we're going to talk about whether to use assessments embedded in the curriculum next week when we do progress monitoring and intensive intervention. But my answer would be overall yes, as a quick answer for Tier 2. And now we'll move on to what to teach. And basically what the panel concluded is that instructional materials for students receiving intervention should focus on number, on whole number for kids in K up through grade 6, essentially, and between grades 4 and 8 really focus on rational number. What we concluded is that the basic thing, the basic goal is number, is teaching kids so they really understand numbers, number line, magnitude, how to operate with numbers, get a sense of estimating everything from quick retrieval of math facts. The reason for that being that that number, according to many mathematicians, and that's a lot what this is based on, is where kids who are having trouble, where they need the help. That usually they are not so bad in geometry. Some do quite well in terms of visualizing transformations and all kinds of things, but when you get to ideas like area, perimeter, etc., without an understanding of squaring, of rapidly how to do addition, how to figure out quickly what perimeter, of a rectangle you're doubling the length and doubling the width. That kind of facility with numbers is essentially critical. Though we had to say the level of rigorous evidence is minimal, and I'll tell you why. It was basically opinion at that point. Recently, we have a little more evidence suggesting we were on the right track. So initially, we were basing this on information that came from mathematicians and math educators who were experts and had thought this through, which is something. These were brilliant people. I had the privilege of working with many of them on the National Math Panel. But one thing that we discussed in quite a bit of detail last week was how the measures that best predict how well kids are going to do in algebra at age 15 is how they do on quick measures of number, especially comparing numbers. And so the work we talked about, Bob Siegler, Ben Clark, and others, their work on how magnitude comparison tends to be the best predictor of future success, tends to be the best early warning sign, is an indication that kids need really bulking up in number, and especially fractions as you get into grades 4, 5, and 6. The other nice thing, and it's not totally convincing evidence, but it certainly is pointing that this is a good direction, is when interventions, and I list some of them here, they're all in the reference list, have focused rather than on the whole grade 1 or grade 4 curriculum, but only on the chunk related to number, which in first grade is really heavily on the number line, as well as, of course, computations and estimation. And in fourth grade is really focusing heavily on the fractions chunk that might be in the Common Core, about a third or so of the curriculum. The results are very good. The results are very good. It seems an area that small group intensive work is good. And obviously, if you're working with kids 3 times a week for a half hour, 4 times a week, you can't do the whole curriculum. But having that focus on building fluency in number is there. But we still can't say it's scientifically proven. The other thing is people have not studied the long-term predictive role and importance of the work on geometry and spatial skills, which is stressed quite a bit in the Common Core, as I'm sure you all know. And that simply has not been studied rigorously yet. It should be, but that is going to take another generation to do. So the other thing to keep in mind in terms of teaching is the emerging consensus on the best way to teach math is that instruction can't be procedures only. It can't be concepts only, and it can't be procedures and concepts followed by occasional work on word problems. That integrating the 3 some of the time is critical, and this plays a big role in this plays a big role. Let me switch to that slide, this plays a big role in what to teach. So the whole idea is we want to have some integration. This is what we don't want to do. And one thing, if I'm looking at an intervention curriculum, I would see if their implicit philosophy is kids need to nail down the procedures. They're at risk, especially by 5th grade, 7th grade. They need to nail down and become fluent in arithmetic before they can understand. That is not true. That is not true, and I would either augment that intervention package or look for something else. These are the last 2 poll items, so maybe if we could do those quickly. Molly, 5 and 6. There's more getting at your beliefs, and then I'll share with you what really are my beliefs and what evidence I use to reach them. What we see happening here, and I think, well, I'll give folks another 10 seconds. Okay, it's looking like most folks agree with my position that some of the time grade level content can be the heart of the intervention. I'm going to nudge people, and I thought it would be much better for you to think this through a little before I go through it myself and my own thinking, and we can move back to the slide away from the polls, Molly, now, is that I'm going to push people to try to do grade level content much of the time. Not all the time, but much of the time. But what I want to do is, in order to accomplish this lofty goal, because you're having kids who in 4th grade are still kind of rocky with number facts and maybe not so great with even pretty rudimentary multiplication and division, is some of the strategies. So this is in some ways the heart of the webinar this afternoon, that Tier 2 intervention, in order for it to succeed, we probably want to lower the cognitive load for students temporarily. Now that doesn't mean necessarily going back to easier material, but that may mean if in the Common Core and in the actual textbook, you're using a wide range of denominators, which is good because you're teaching the general case. So you're dealing with magnitudes, but you're dealing with fifths and tenths and sixths and thirds and eighths and sixteenths. You may need temporarily to use a much smaller set to get that grade level standard down, but start with a smaller set, maybe only halves, quarters, eighths, thirds, and sixths. So the idea is to temporarily lower the cognitive load, and I'm going to show you a couple of examples from successful interventions. And because students who need intervention, sometimes they have problems with working memory, sometimes they have problems with motivation, sometimes they have problems with sustaining attention and persistence, sometimes they have problems with all of them. But what you want to do to work around it is you want them to be successful, but you want to give them an opportunity to think and feel successful and get feedback on that. This is another assumption. This comes from 4 decades of research, what was often called in the LD field or special ed field or the direct instruction research, is that systematic and cumulative review is essential in Tier 2. And I would suggest if your curriculum you have, which may be brilliant in other ways or that you're using, doesn't do it, work out a way that your kids get it. This could be done at a grade level, a district level. It could be done through a BOCES, a way to supplement it so kids get review, because otherwise it's going to be harder for these students to retain the material. And in math, thousands of ideas are interlinked together. Another thing that I would see going on, not necessarily every single lesson, but very frequently, is quick retrieval. Building skills so that even when kids grasp the idea of equivalence, you want to make sure they can do that pretty quickly, pretty fluently, because otherwise equivalence is assumed as they get into the more complex adding fractions and subtracting fractions with unlike denominators. And you want this to become pretty quick. So having some time every lesson or every other lesson that's timed is hugely important in terms of a framework. And this is another thing. This is probably especially important to look for if you're using interventions aligned with core programs that sometimes accompany them in the teacher's guide or whatever, is these kids will need a lot more practice, a lot more examples than your average learner, and that is the way it is. And if you need to add them yourself from their sources you could download, work as a team, but they need a lot of practice. So those are broad assumptions. I'd urge people, and these are much more controversial, to teach grade level standards wherever possible. As someone said during the chat at our last seminar, that for high school kids, to get them in and to get them motivated, if they're 10th or 11th graders, if it's algebra or geometry, you have a shot at it. You may use easier examples than the core class, but if you're still doing with them 5th grade fractions, the attitude is very low. Even for 5th graders, wherever you can make that link, because then you can play on the synergy so they can comprehend what is going on in their regular core math class. So that is pretty critical. In many ways, the principles that we talked about at the first webinar that are available in the archives, many of the principles of good at Tier 1 instruction are true here. Tier 1 is hardly like there's one ideal way to teach math, but the integration of procedures and concepts and word problems, and those things are great to have in Tier 2. And this is the other thing to really think about and to share at times with your students, is that your ultimate goal in Tier 2 is that you're obviously building proficiency in the material there, but you also want kids to understand. You want them to develop insights. You want them to talk to you about their reasoning, how they prove things. That is not easy to do. In general, some of these students have been shown to be the type of students that don't handle organizing abstract material very easily on their own, but teaching the language of math is critical, and we'll show that in a little bit in a video. Before we move on to how to teach, I'm going to fairly soon show you a video, but I want to review the material in the practice guide that I showed last week, and I've winnowed down the 8 recommendations to the 5 that relate to how to teach. And let me share a couple of side notes to what's actually in the easily downloadable on the website, and I have that information at the end, the practice guide. when I looked at the actual studies that had good effects with at-risk learners, which now would be called kids in Tier 2 or preventative interventions, this was the two key things that stood out. Even though when you read the front end where the authors talked about their philosophy, did their literature review and all, they talked about explicit modeling, explicit instruction, etc. When you really looked at what they did, the procedures, and actually I went through the studies that passed muster myself to check for that, these were the two things that stood out. They were incredibly systematic. That is not true for most math textbooks, but the intervention approach was very systematic. And it was focused. It didn't try to cover everything, but it covered that stuff in depth. It really was focused. And now, the art in good intervention teaching, and I'm sure many of you are good, excellent interventionists, those of you who do direct teaching or have done that in the past, is to not make it tedious. You can have extended practice and make it interesting. You can add games to things. You can have challenge problems. There's all kinds of ways to do it. But that one, there's strong evidence, and that is not going to go away, I would predict. We have another 50 studies to review in 5 years, or my successor does that. That's not going to go away. Solving word problems using, and I'm not going to spend much time on this today because many of you are familiar with it, either from the textbooks or from some of the work going back to cognitively guided instruction. There are structures for helping kids sort out word problems and figure out how to make sense of them mathematically. And I'm sure most of you have seen them. I have a couple of examples at the end. But those tend to work wonders with this group of students if they have enough time so they really understand it. So it's not just that they're exposed to it, which will be more typical in Tier 1, but they really are understanding it and good at it, and that also allows them to learn the language of math. Visual representations, the evidence was moderate, and the Common Core stresses it so heavily. I would urge like a green light on that one. Fluency with math facts, that has been determined starting in the late 1980s. It's a real hallmark of a math disability is being disfluent with math facts, not being able to, even at an age where you should know that 9 and 7 are 16, having to really think about it, kind of really calculate it, use stick figures or something. You'll be lost in a 4th grade lesson, be it on multi-digit operations or fractions. One question is, someone was wondering what systematic means, and I guess the whole idea is, I'm not sure there's one thing, that there's a clear goal and it's chipped away at using examples that are relevant, so a lot of time goes into understanding equivalent fractions using concrete representations, using actual numbers. It's continued. Students are reminded of that as they move into operations, etc. I also notice people are getting a bad storm, and is why they're late. But that is one thing. I don't know if I have the exact, precise definition of it, but you can see it when you see it. So there's nothing wrong with the recycling, the old, the idea the Common Core has some of that. You want to recycle stuff, but you want to explicitly link it to what your goals are and having a really clear set of goals for folks. And the fluency we talked about with facts and use of motivational strategies, there was no evidence. Now, the National Math Panel report had come out, and somebody said, well, they stress it. You had all these great psychologists, David Geary, Bob Siegler, But this was the problem. It came from science. So we just don't have hard research on it. We have some studies where there was a motivational system to it, and I'll show you a little tidbit of that. But that was part of a package with so many other things. So we think it's incredibly strong. My personal sense, the evidence is minimal, is very often, probably at all age levels, but certainly at the elementary level, is you want to have some extrinsic system for building motivation so that you can develop the intrinsic one. So this is a key recommendation that interventions be systematic and that somewhere or other kids get to verbalize the thought processes. Now, this is what intentionally we left open. Do kids need to develop these on their own versus do you need as an interventionist to create a situation where they develop it on their own versus do you tell them? This is the thinking that goes through my mind. And the answer is it's not clear. Probably, I think ideally a mix of the two is the same. I'm going to give you an example of one, though unfortunately this was filmed with a group of kids that are not in intervention kids, but where that same teaching protocol could be used with a group of at-risk learners. And I want to walk you through how that process can be guided. I think you're probably more familiar when kids are told a strategy. And that definitely does work with kids, but the drawback is you don't get great generalization. Evidence, we had at that point in time for the systematic instruction 6 randomized trials that met highly rigorous gold standards, so we were kind of doing what the FDA does. And the cumulative review kept forcefully hitting me as a key theme. And the other thing is, somewhere or another, there are a lot of models of how to solve the particular problem at hand, be it a computation problem, a word problem, whatever. There was no one specific way to do it. A lot of the research studies were very much, those of you familiar with the SRA programs, very much step by step, this is exactly how to do it. That way can work, can get results. I think there are other ways that also can work, but what you want is many more models. A typical core lesson will have either 1 or 2 models, and then kids kind of work on it in groups, and we need more than that. Some of the roadblocks to this, and I alluded to them briefly before, so I'm going to quickly go through these, is if it's not in your instructional materials, develop supplements for you to use, and probably some of you do use at times sometimes paraprofessionals or parent volunteers to do parts of your intervention, parts of your RTI. Materials especially need to be used for that group, but sometimes there's simply not enough review problems. Those can simply be added in. But those are the key components for something to work with the kids. The other roadblock is kids may never be asked to explain their reasoning, and you can develop some prompt cards for those delivering the intervention, be it you, those folks you supervise, your colleagues, so that they have times where they ask folks to do that. We now are going to switch to this video, which is, as I said, the students are not intervention students, and the key thing is getting kids and shaping for kids, and this can be done in interventions, to use appropriate mathematical language when they explain.
Division of fractions is often a challenge for students. This is particularly true as students are making sense of a solution that is greater than the dividend. How can it be that you end up with more than you started with when you are putting the amount into groups? Watch as this class continues to work with division using pattern blocks. Notice the focus on the language of division, which allows the students to make sense of the problem. We are going to work some more on division of fractions, and today we're going to do some story problems involving division. Okay? So with this, we're going to be building models. So you'll see that you have pattern blocks, you have Cuisenaire rods, and while I'm passing these out, can you guys also underneath your desk grab your whiteboards? And in your pencil tray are the markers. I think I counted right there. So some of us have understood some of the procedures, but I want us to think today, we've got an extra one, thanks. I want us to think today specifically with using some representations to help us do some of these problems. Okay? So as a reminder, when we're using our whiteboards, do we get to scribble all over and write love letters and notes across the room? Do we get to put our boyfriend's name or who I heart right today? Right? Okay, so just a reminder, everything on our whiteboard's got to be about math. About math. Just got to make sure we remind ourselves about that. So let's start with the very first problem. And on your page that I just handed you out, there's a side A and a side B. I would like you guys to be on side A. It should have like a picture of a scissors on the first question. Okay. You're going to have some choices in a minute. We're going to work some problems, but we're going to do just a couple together because I want us to be really clear about the question for division. So before we do anything, let me write up this problem for you. Four divided by 2. Pretty easy problem, right? Yep. What question does this ask us? Ben?
How many times does 2 go into 4?
How many times of 2 goes into 4? What's another way I could say it as well? Let me slide down for you guys. Now we can see. What's another way I could say it?
What times 2 is 4?
Okay, we could turn it into a multiplication problem. What else could I say? Yes?
How much is it when you divide 4 into 2 parts?
Okay. I'm going to write it kind of how we talked about it, how it was said the first time, but I'm just going to add one thing. When we talk about multiplication, don't we multiply saying 2 groups of 3 or 5 groups of 8 when we multiply? So I want to keep with that groups language that we do, and this would say how many groups of what? How many groups of 2 are in 4, right? Okay, how many groups of 2 are in 4? 2. Okay, so what if this said 4 divided by 1/2? What would it say in words, first of all? What would 4 divided by 1/2 say? How many groups of 1/2 are in 4? So let's just think about that one for a second. Let's think about that one for a second. Now, if I use my pattern blocks for a second, okay? If I use my pattern blocks, would you guys agree that that could be 1, 2, 3, 4? Would that be my 1, 2, 3, and 4? What am I using for my whole? One hexagon is one whole. The question is, how many, what? What's the question? How many halves? If the hexagon is my whole, what would I use to represent the 1/2? Who else knows? Who else knows? Who else knows? Evan? A trapezoid. Evan's ahead of me already. He's got his blocks out. Is that a half of a whole?
Yes.
Yes. So how many 1/2s are in 4? Some of us are counting. There's 8 of them because there's how many here? 2 and 4. So 4 divided by 1/2 is going to be 8. Division of fractions. I want us to think today. We've got an extra one thing. Specifically with using some representations to help us do some of these problems. Okay? So as a reminder, when we're using our white,
Divide 4 into 2 parts.
okay. I'm going to write it kind of how we talked about it. What would I use to represent the 1/2? Who else knows? Who else knows? Who else knows? Evan? A trapezoid. Evan's ahead of me already. He's got his blocks out. Is that a half of a whole?
Yes.
Yes. So how many 1/2s are in?
Anyway. Oh, Molly, we need to stop the video. Okay. Okay. One thing is, you can tell this is not an you could tell it's not an intervention group. One second. Because that trapezoid answer, I mean, that kid was a lot faster than me, for example, in doing that. But the key point is that this approach can be done with an intervention, and I think would be an ideal lesson. Now, I asked numerous colleagues, I just could not find videos of good Tier 2 lessons. People write articles and the teacher's guides and whatever, but this was the closest I could come. But I think that idea of having kids really discuss and think about that you can divide things into, find out how many times a group of 1/2 goes into 4, requires some discussion and all. It's not as simple as the teacher modeling and telling them things and that kind of thing. So I wanted to show it for that reason. People have been asking me in the chat box for resources. I don't myself know of any. One possible thing, maybe Molly could check with the folks who coordinate the RTI-TA for New York State. I know Pennsylvania with the patent network often does a lot of innovative things. There may be things available there. But I think these guides do need to be developed. They're possible. They're basically possible to do. Let's move, Molly, to the next slide. Can we do that? We're having some glitches. You want to try mine? Yeah. Okay. Oh, there we go. Yeah. Okay. Okay. Here we go. Okay. Now we're back to normal. Okay. The visual representations is something I want to spend a bit of time on. I know it's there in the Common Core, but it's there, and there's tons of it, but people need tools. And the intervention publishers, as folks commented last week, they often say it's aligned with the Common Core, but when you look at it, it means everything in there is in the core, but there are a lot of things in the core that are not there are a lot of things in the core that are not covered at all. So visual representations are keys. And then I want to give you an example from another program. This is research by Lynn Fuchs, as well as some of the ideas of Sibylla Beckman on visual representations. This is, to me, best practice, and I'm going to go through the two maybe unique points that I want to stress slowly and repeat them because they're not easily grasped and they're not grasped by all. Certainly using visual representations everyone agrees with. The Common Core says you got to do it, etc. So that is fine. One unique thing is strip diagrams of all the visual representations. I'll show them to you in a second. Strip diagrams need to be used much more. They are the key visual representation used in Japan, in Korea, in Singapore, in many high-performing countries. So I'm going to urge that you use strip diagrams possibly more than whatever intervention programs you have or whatever core programs you're adapting your interventions from. So that's one key theme, is the use of strip diagrams and why they're incredibly important. The second is expeditious. Now, if this is a model some of you may have heard of, CRA, concrete representation, abstract. Brad Witzel and Paul Riccomoni have done a lot of research here and talk about it a lot. It's moving from concrete to visual representations, such as circles and strip diagrams and rectangles, to the abstract symbols, be they numbers or of algebra. And the key thing is expeditious. Continually, observational research shows a lot of use of manipulatives is not linked to math. These need to be used quickly, expeditiously, with a clear purpose, and move right into the visual representation, as you saw that teacher doing there with her hexagons. You want to use them, but you saw how expeditiously that went right back to the verbal symbolic division problem of 4 divided by a half. The other thing is there's sort of an informal rule of thumb. Manipulatives, concrete objects are used K-5, and then they're not used in middle and high school. What Brad Witzel has used as a basis for a lot of his research is that's wrong. You want to expeditiously use them in the upper grades, especially in intervention, because what teachers tend to do is they go right to a visual. Often it becomes a graph or something, or it's another kind of visual. But some kids need to see the concrete thing because they don't deal well with abstractions, and you still need to use it expeditiously. Those are my 2 key points. The practice guide said them. I can't emphasize them enough. I'm going to give you a little detail on each of them and show you a bit some of the core thinking behind a successful intervention work in fractions that Lynn Fuchs' colleagues have done. This is an example broadly of the more typical thing, the array of things that you'd be using in an intervention for 5th graders that is covering basically grade level material, but you're using the abstract level, the 1/8, you're using the number line, and you're also using a relatively limited number of visual representations, in this case squares, rectangles, and circles. And of the 3, the one that I would move kids to and hit the hardest is C, and let's see why. It is the easiest one to phase into the number line. If you go from C to a number line, especially if C was very, very skinny, it's easier to phase in than going from a circle. There's no way we intuitively link those 2 together. And the other thing is, what we're building, and I spent a lot of time last week talking about that, is you're building you're trying to build in kids, according to a lot of cognitive psychologists, what really math development is the development of an increasingly sophisticated mental number line. That's really what you're trying to build in kids. And if you really know and love math, like I'm sure a lot of you do, you know we all have that. My friend Dick Askey, a brilliant research mathematician who's now in his 80s but still active in terms of Common Core standards and assessments, said that mathematicians spend 80% of their lives on the number line, and he overstated it, but this is an example of a strip diagram. You see where it's even skinnier than the one from the Fuchs study. It goes easily into a number line, and this is what I would have kids do, and you can also see why some kind of fractions tiles are great because they're concrete, but they lead easily into this strip diagram, so this would be my core set of tools. I use the others, especially you want to use the circles for the intuitive sense of sharing. You want to occasionally use the hexagons and all because you're showing the linkage between math ideas and geometry, but those are the key ones to use. This is a problem, and just think about it and do it in your heads in a minute. This is a problem, and then I'll show you in a second. I want to go through the strategies adults use and then how a strip diagram could be used here. So, not a killer problem, but not one so easy that it's insulting for an adult. When I've asked adults to do this in live events, these tend to be the types of responses you get. Some do, like the way I would do it, is you just do the equation 2/3 x equals $26, and you solve the equation. Others, especially those probably who are teaching elementary, mid-school kids, say something like that, well, we want to know the whole, how much money she has, but two parts of it, two shares of it. If you're like me and you like occasionally investing in stocks and mutual funds and figuring out what's going on, you can think of shares, which, by the way, sometimes kids love when finance is tied in. But anyway, verbally, that's a way to think about it, and some people just intuitively do it. That's probably not that many. But one thing I want you to notice here is why we can link algebra very easily to the word problems we're doing in elementary school, because it's exactly the same process. But if kids are used to solving these problems and verbally reasoning them and showing you their reasoning, algebra doesn't become such a mystery for kids. This is how a strip diagram could be used. That strip diagram stands for a unit, and kids know that. So that's one unit. So you know that's her thing there, and you know that there's something about it, two parts, that because 2/3 means 2 parts out of 3, or 2 parts out of the 3 parts, or 2 parts out of the whole. So this strip diagram could reinforce that language, and kids can learn that. A key philosophical thing that, and I'm going to quickly give you a sense of some of the highlights of Lynn Fuchs' work, because I want to allow the last 15 minutes or 10, 11 minutes for questions, because we got some very interesting ones. Her belief, and she's articulated, others of us have maybe not articulated as well, you want to temporarily reduce the cognitive load. So I would have that in mind when I'm evaluating an intervention curriculum, or either working on or accessing or trying to access these guides, though I hate to say it, maybe that would be a great thing for a BOCES or for New York State to do as part of TA, a guide that could adapt some widely used programs. But what you wanted, so one thing she does among many, I mentioned before, you start with a much narrower range of fractions, but the other is she uses a half as a benchmark a lot. So this is teaching number lines 0 to 1, where fractions go on it, and this is incredibly important. These are the goals. These are reasonable goals for an intervention, a Tier 2 intervention, for kids in the lowest third based on nationally normed tests. But the 1/2 benchmark is stressed, and that seems a great idea. This doesn't show it, but these are the kind of problems kids are approaching, and this is what you want them to be able to do, to put these 2 on the number line and explain to you why 9/12 is bigger than 3/8, or 1/5 is bigger than 1/10. And so this is ultimately your goal, but a special step is added in here of comparing fractions using 1/2. So what actually they do is, rather than starting off, when they get to this quite hard skill, magnitude comparison of 3 fractions, at first, 1/2 always shows up, because kids are taught that 1/2 is a great benchmark that can be used. And by doing that, it demystifies the process. And so I'm trying to get at the heart of her curriculum. So here would be the kind of thing they would do, and again, because it's systematic and there's a lot of cumulative review, they do this probably over a period of a few weeks. They'd be seeing this number line with a 1/2 there, and this is their big task, their ultimate goal, what you want them to be able to do and do well on the end of the year assessment and their classroom regular tests and assessments. But first they're with 7/8. They work out their different ways, a number line with 8s, and well, they start to learn. They start to be able to quickly retrieve that 4/8 and a 1/2 are the same, so 7/8 is bigger. And they put it on the number line. Then they go to 3/12, and they do the number line. Then they break this into 3 problems. So this is what I say, there's a system to it. Often this problem is thrown to kids at that grade level. Here it's broken into all these subtasks because each one becomes more manageable and doable. So that is the philosophy behind this intervention that had pretty incredible results. In fact, on the fractions part of the 4th grade curriculum, these kids in many areas, including computation, did better than the upper 2/3 of the kids and the classmates who were in the upper 2/3, because they had sufficient time on it and things were broken down into units that were comprehensible. And I've just given you a framework. The last 2 are ones, I've really talked about the core message and all, and these I'm going to spend the last 3 minutes on. The 10 minutes to build facts, I think, is often good. I think computers can do it. Should it be 10 or 20? I don't know. 23 times a week could be good. The great things about computers is for fact practice, except in 1st grade, almost any other grade, they are wonderful. They're wonderful because they have infinite patience, and also they know which facts kids need work on and which are the facts they want to just put in a review cycle. This is a very easy program to develop. There are a million programs out here, so this is a good use of technology. So kids are just practicing facts so they can do them. And the other thing is that and I'm sure most of you know these, the ways that you can figure things out in your head that many of us learned or taught ourselves. So if you have 9 times 8, or 8 times 9, you could do, it's 8 times 10 minus 1, and then that's pretty easy to do using the distributive property. But kids need time to explicitly teach that, but this is then going to increase their fact retrieval dramatically. And there was a study showing that a combination of that and the computer really helped kids generalize their knowledge of facts, saw that multiplication facts and understanding multiplication are really related together. So intelligent work on facts, the mix of some drill, some kind of fun stuff with these neat things, which is also, again, developing algebraic thinking, would be great. Motivational strategies, though the formal evidence is minimal, I'd encourage it dramatically, especially because correlational research shows that even more than in reading, kids who in kindergarten have intention problems tend to wind up needing help in math. I think there is an abstract part to teaching reading, which relates, to phonemes and these ideas that one letter can represent several different sounds and rules are broken and all. But reading has a lot of other stuff that's not so concrete. That's not so abstract. Math gets abstract easily. So the motivation problems in math interventions often have been more of a struggle, the attention problems. So I would try to build intrinsic motivation through interesting, captivating problems as part of your thing, but let's also have extrinsic things. And Len had fractions money and their stores, and you folks know a lot more about this than me, but just ways to, if kids are really working hard for 3, in some cases, or 5 consecutive minutes to do that. And this is just an example of the system she used in those successful things. And the word problems, I'm just going to show you in a second. I'm sure you're used to compare problems and change problems in 3rd grade, and these are examples of the kind of problems that come up in textbooks. I think the thing that the research has added in is a lot of times when you ask kids, is this a change problem, a compare problem, a grouping problem, and then you ask them to solve it, it gets to be too much. So what the successful interventions that Fuchs and her colleagues did, they broke it into 2 phases. One is all kids had to do is tell me, is this a change problem, is it change over time, or is it comparing what's bigger? That's all they did. They didn't have to do a lick of math. Then, when they really were good at doing that kind of sorting, then they were asked about the operation. Is this one I subtract or add? And then they added the math in. So again, it was broken down and systematic. Quickly, these are 2 great resources. I think Molly has put in the chat box and can possibly share other resources that New York State has. I don't know if they have the specific guides, but these are places to just keep track. The National Center on Intensive Intervention has tools charts, which includes intervention. They also have a lot of other neat material. Sarah Powell, who will be sharing the webinar with me next week, really knows that center well and can share more on resources there. What Works Clearinghouse does simple evaluation reports, but it will tell you about effective programs and what the data is. But the National Center does provide instructional tools. We need a lot more in math. There's so much in reading. And this practice guide, you can just download it. It's a good source book, a tool book, a good book to share with colleagues. There's some good examples in there. It could use updating. If you think it needs it, just tell. There's the What Works website. They're always asking any ideas for new practice guides. Tell them. These are the citations for those of you who want them. And this is a recap of the framework, but I'll leave that up and I'll start responding to some of the excellent questions that have been coming through. And Molly will chime in when it's really time for me to shut up and for you to fill out forms. So start with the first one. Hopefully I've given you at least a flavor for systematic. So would you please give me an idea of contact time with these number of students? I can tell you about the studies because that's written up and all. What those studies were typically groups of approximately 4 students for 12 weeks, 3 times a week for a half hour for fractions. So that is, what would I do for an effect if I had my say about scheduling it? I'd say ideally intervention would be 4 days a week seems to work well. A lot of times it's just good to have a day off. 3 could work too. Half hour seems a good amount of time, especially for younger kids. I think in mid and high school, it's easier to answer the length of time per day is how long the period is. But I think it would be wonderful if we started developing creative tools for kids who, sometimes it's called double dose of math, kids who are, below proficient on the state benchmark or on whatever screener is being used, to give them that time in a small group. I would use, the researchers tend to like groups of 4. I think you could go bigger than 4. But I like the idea that people are thinking about placing kids, because a divergent group of 4 or 6 is a horror to work with because you're like at 2 different levels. So hopefully people now, the question was on strip diagrams. I'll maybe quickly go back to just make sure it's reinforced what they are. I just wish they were called skinny rectangles, because that's what they are. This is strip diagram. If you look at any Asian book there, it's there, but it's a skinny rectangle. It could be used, right, for part, it definitely can be used for part whole, but the pizza's great to orient kids, to introduce them, but the advantage of these is it fades so easily into the number line, and you get kids thinking essentially of an x-axis from when they're in the 2nd or 3rd grade, and that's what we want to do. We have such horrible failure rates in algebra, and kids, if the x-axis is second nature to them, that will be wonderful. So we have a question. Dr. Gersten, I have a 4th grader who's struggling significantly with no number sense, difficult with even basic math, lost as to how to intervene. This student, and what experts are now saying, this is a student who needs to go immediately into Tier 3 intervention. And what Tier 3 intervention is, it is not a formal special ed referral. It could ultimately be related to one, but it is individualized. And I see it as individualized in this way. There can be some one-on-one time, but the student is getting resources that are appropriate for her needs or his needs. Now that could include time and should include some time in the classroom on the grade level standard, but that time may need to be truncated because of all the backup work that needs to be done, and may focus, for example, on a much more limited sense of denominator. So I wouldn't deprive a 3rd, 4th, or 5th grader of work with fractions, but it might need to be just to get those concepts going. But I think the key is that's definitely Tier 3, and we're going to talk about that next week. And Tier 3 very often does involve below grade level material, and that really is an area of expertise of Sarah Powell. And it's nice, someone said that modeling and having kids practice the steps verbally does help. I agree. I think these words are not common parlance words, and they need to practice. It's almost like a second language. You're just practicing it, because they may need to practice it using initially your language or the the textbook's language, and then they can start to own it. I think it's also our special ed techniques of sometimes starting a task for kids and letting them finish. So maybe they're not giving you all of their reasoning, they're just giving you one step in the process, but they themselves are verbalizing it. It's great. That was Vygotsky's insight almost 100 years ago, that a lot of thinking is like internal verbalization. Let's see. So Molly said, okay, well, I'll just go through a few of these comments. So that's one reason. This session originally, the state had asked for it to be Tier 2 and Tier 3. I think Tier 2 is different. Tier 2 should be preventative. I think most of your Tier 3 students would be in Tier 2 as well, because they're getting grade level material presented to them at a systematic fashion. Some of these other issues that came up, are there guidelines for inclusive 5th, 6th grade classrooms? I would say this, that most everything in the practice guide would be your basic framework and the material in this webinar. That doesn't mean those are the specific instructional tools, but those are the principles I would use. It would be great if there were 2 adults there. I think the use of groups, there's all kinds of creative ways to do this, but I don't think the principles change. Molly has a New York State website that she'll post. They'll be available to everyone. Jennifer Jacobs said, I believe, Engage New York calls strip diagrams tape diagrams. That's true. I'm sure there are other words. Don't forget, a lot of this came from Japan and it's Korea, so people, bar models, I think the whole idea is, and I think Lori Rolfe in her comment makes a great one. She says she thinks strip diagrams relate to using fraction bars rather than fraction circles. That's exactly right. It's the idea, if you think really skinny rectangles, so sometimes they're called fraction tiles, fraction bars. I think you're on the right track. Have kids use those. That is going to be harder at first than the circles, but it's going to get them to think about a number line and get them and get them moving forward. Natalie made a great comment before we wrap for comments that when you ask kids to verbalize, you can catch their mistakes. I want to say amen for that. If I ever do a webinar like this, I'll put that in there because that's exactly why. I want to thank you very much. Great chat, and this is pretty intense material, but I hope this gives you